Hello viewers and welcome to a new live stream here on YouTube. Yesterday I did a live stream where I created an STM32 development board, STM32 World Development Board based on the STM32F405 mysterious microcontroller that doesn't exist outside China. And I decided to try to live stream creating that in KiCAD or KiCAD. I really don't know. I tend to call it KiCAD, and I'm sorry about that if that's not how it's supposed to be pronounced. But that's just how it is. But I realized what I did yesterday was I took my earlier STM32F405 based board and I just swapped the microcontroller on that. And yeah, well, I mean, it was definitely the fastest way to do it, but as a learning KiCAD or KiCAD experience, probably wasn't very good because I skipped a lot of parts, and so I decided experimentally, I still don't know whether I'm going to do these regularly because it's a bit different to do live streams than it is to do. But let me experimentally try it. First of all, my setup, if I need to do live streams often, I might have to change this. The problem is I'm working on two monitors and I don't have them evenly distributed in front of me. I have one monitor that I usually work on, which is straight in front of me, and then I have one to the side, which is why I sometimes look over there, which is not the one I'm sharing, and on that I have the recording tool, which is OBS, and I have the, well, basically everything else. The problem with this setup is that your chat messages, if there are any during this, is way over there, and even so far away from me, they are a little hard to read because it's a small font. So I might not actually see your chat messages. On the other hand, that means I can actually concentrate on the streaming. So let's see how it works out. It is still very much experimental. So I am loaded up in coffee. It is relatively early in the morning here where I live, and I think I can go on with that coffee. I can probably go on for an hour or two. Let's see, and let's see how it turns out. Now, I had to think of a project to do that would be informative and not completely idiotic and interesting enough. So I decided on creating a board with some RGB LEDs on the board that can be controlled with I2C. Again, pronunciation, I call it I2C. You can argue all you like. I'm not going to change to I2C. I call it I2C. So I'm going to create a board where you can control some RGB LEDs with I2C. And one of the reasons I decided to do this is some years ago I came across a component out of China called the AW9523 GPIO expander. A GPIO expander is typically, if you have too few GPIOs on a microcontroller, you slap one of those on. There's a very famous one called MCP23017. They're usually about $1 a pop, and they will give you 8 or 16 extra ports that you can use just for two. So you can use two I2C to drive 16 outputs, and that's essentially how these work, these GPIO expanders. But the AW9523 has a little bit of a party piece. It's got a built-in LED driver as well. Now, if we look at the data sheet, which I have here, highly confidential. Sorry about that. I don't know. I just found it on the internet. You cannot keep things confidential on the internet. Give it up. It's basically got 16 GPIOs, which you can let drive. And the interesting part is that normally when you control the intensity or brightness of a LED, you will use pulse width modulation to rapidly switch the GPIO on and off. This one doesn't. This one actually controls the current. So if you put a scope on these channels when you're actually using it, it is actually completely regular voltage. It just basically regulates so to control the current, and that is a pretty clever thing actually. So you can hook up, where are we? You can hook up to 16 LEDs to the different ports, and you will see you don't even need a current limiting resistor in series with the LEDs, because this one controls the current 100%. These GPIO expanders are also really dirt cheap. You can find them on LCSC. They have 20,848 in stock, and you can buy them for 36 cents a piece. I've seen them cheaper. You can get them down to about 20 cents a piece if you buy them in volume. So my thought was, rather than hooking up 16 individual LEDs, we could do that, but would that be more fun actually? Because you could use some nice patterns. But never mind. I'm going to hook up 3 RGB LEDs. No, 5 RGB LEDs. Why 5? Well, 5 times 3 pins on each RGB LED, that's 15, and that is, so I'll leave one port unused on this. And that is about it. So I'm going to create a project where I put one of these on, make a header where I can control the I to C, and then I'll hook up some RGB LEDs. And there are thousands and thousands and thousands of these, but I found on LCSC Electronic, I found from Singlight, I found this one, which is quite tiny. And I think, okay, let's do that one, and let's look at the data sheet, and we will need that data sheet readily available. So here we go. It's I don't think you can find an English data sheet from this one, but I also don't think I need it. This one is extremely flat and it's quite tiny, and so let's look at the design of it, which is where electrical. Yeah, okay, they didn't bother. So here you have the physical packaging, the recommended soldering pattern and footprint, and here you have the 3 RGB, 3 individual LEDs in a configuration called common anode. So the anode is common, and that is the one we'll just yank that up to the VCC, and then we will have the individual LEDs straight into the GPIO expander, and that is about it. So this is sort of the design. I should maybe have written a little more about it, but since I am going to show this from scratch, that is what I'm going to do. So we call this the I2C RGB LED board. So my first step before doing anything else would be to go to GitHub. And I don't want the STM32 fun. I want GitHub. I want my personal GitHub here, and I am going to do a new repository and show you how to start this from scratch. So here's my repository. I'll create a new one. For now, I'll call it I2C LED. I'll just call it that. I don't bother with anything right now, I will make it private for now. When it's this much work in progress, I'll usually keep it private. I will add a README file. I might as well add a C. I can add more later. And I will not bother with a license right now. We can do MIT license. I might change that at a later point. So let's create a repository here. So now we have a repository with a few files, and I am going to copy that, and I am going to go. I have to be careful not to use that window as long as I'm in the way. So let's go over here, and I go in. I'll usually put everything in source. I'll do a git clone that. Right. So now I have a folder called ITO-C-LED, where I have these two files. The git ignore file is hidden. It is there though. So let me show you. It's there. So there's also a JIT folder. That's always when you work with JIT, there will be a JIT folder. So that is about all we need to do here. So let's fire up KiCAD, and in file KiCAD, I'll create a new project. I will browse to my new folder here. I will create a new folder there, which I will call PCB. What happened there? Did I? Okay, I'm there already, and I will call it ITO-C-LED. As simple as that. I will uncheck this one because normally KiCAD will create a new folder, but I like to control what is called. So I'll just call it PCB, and I will save. That is it. I now have a blank project. We can go into the schematic editor, and it is completely empty. So that is about the start of this. Now, I will usually do a couple of changes in here when I start up a new project. I like to do a few things. First of all, I like to go into Manage Simple Libraries, and I'll do a project-specific. No, let's not do that for now. Let's just get started. So wait, how would I normally do this? I'll go into the simple editor, I think. And if I'm in the simple editor, I can file. I'll create a new library, which I make a project-specific library, and I will call that, leave it in the same one, and say ITO-C-LED KiCAD Sim. That means I have a library that I use just for this. Let's go back. Where are we? So this, I will do the same thing with the footprint editor. I will create a new footprint where I can make my own footprint. I'll probably need to create my own footprint for the LED. We'll see about that. We'll create a new library, and this again will be a project library in there, which we call ITO-C-LED. Pretty. That's it. So now I have a footprint library, and I have a simple library, and I can start working on the schematic. Now, the first thing I do is to set up the schematics. I know a lot of people are skipping this, but I think it's absolutely essential. So I go into my schematic setup and I go down to text variables, and I usually will add a few variables here. I add a title. We call that I2C. I will do a revision, which I call A. I will usually do a few more. I will usually use order. I'll put myself in there. I will usually add an author email. These are just some I started using. I'll use my Gmail. I usually put a URL and a copyright and all that stuff. I'll put variables in. Save that. Now I will go to my page settings and I will actually use these meta variables in. So I'll put the revision in. I will put the title in, comment. I'll put author there. I will put author email. And if you look now down in this block, it's got the basic information. So we can save that for now, and we have a good starting point. So let's start actually doing this schematics. There's a few things I know I'm going to need, so we can start putting this in. First of all, I'll need a generic connector, and I will use a standard 100 mil connector. I will need VCC, ground, clock and data for the I2C, and I'll need a reset pin. So 5 pins, so 1 times 5 will be my header, and I can, how do you, I'll put that in. There we go. Is it Y? No, it's not Y, it's X. I'll flip that around. There is, okay, we can leave it that way. So we basically have this header, and we will use that one for VCC, that one for ground, I don't know, maybe that one for reset, and these two for I2C. Let's see how the easiest way to do this will be. Next up, let's actually put in the LEDs, because I found that I can actually find those in a GB LED. They have them here, all the different LEDs in 3 packets. So we need to find one that matches our, where is my browser? Okay, it's here. So let's look at the schematic of the LED. It's here. So we will have the common anode on pin 2, and then red on pin 1. Let's find that and double check that it's actually correct. Yeah. So let's have the common anode. I don't know why. Okay, red on pin 1. So this one is definitely wrong. This one is wrong, but it should probably be called, I don't really fully understand this naming. Exit scroll, so we need 2. Here was 2-1. It's one of these two. So where did we want green? Blue on pin 3. So blue on pin 3. There we go. This is the one. So we need this one to be put in. We need one. I basically, yeah, okay. This is a little hard to show, but one of the things about KiCAD is you really need to use the hotkeys. So I need to get used to in this video to explain the hotkey. Now I have put this in, I can press Ctrl D for duplicate, and I can duplicate this one to another one. I can duplicate it again. And that was stupid. I'll get back to explaining why. It is better to have it completely configured. Set or the E will bring you up the property. I think it's short for edit. I need to put the footprint in. I need to put the datasheet in. We can start with the datasheet. That is easy enough. Which I have the link there. So go to datasheet. I will immediately create a new field here, which I will call LCSC, and put in the LCSC part number, which we actually have as part of the datasheet. It is this part, so this will be the LCSC part number. I'll put that in while I'm at it. Still need a footprint. So that will be next up to create a footprint. So let's look at let's create a footprint for this one right away. So because I don't necessarily, I might be able to find one, but it can be really, really hard to find these footprints. So it's quick enough to make. So let me create a footprint for this device. So I go into the main menu, I fire up the footprint editor. I already have my library that I created, so I'll do File, New Footprint. Here we go. I need to create some pins. Let's follow the pattern they use in the datasheet. I flip back and forth here. That's basically to demonstrate it for you. So 1, 2, 3, 4. Okay. So normally I would just have it on 2 different monitors. So 1, 2, 3, 4. So that will be the rough layout. These needs to be 0.45 times 0.65. So let's try to do that first. So I click edit to edit this. And what is it? Default. Oh. So Y needs to be 0.65. 0.65. And yeah, 0.45. So Y 0.65, 0.45. We can probably put the position straight away like that, but let me wait with that. First of all, let's center this stuff. let's move that out of the way, and let's move these up centered around the here. And actually, let's use duplicate again. Let's get this one correctly. Wait, I must have flipped them around. It's supposed to be taller than it is wide. So, sanity check here. Oh, of course I'm an idiot. 0.65, 0.45. Here we go. So it just came in. What are you making? I'm making an RGB, I2C RGB LED extender, and I did explain earlier that I can't really see the chat easily, so I won't notice that probably. And I'm starting from scratch. That is the whole point of this one. Let's see the location. So you will have a position X, which is minus, and that is to the center line. So if we look at this position, there is 1.25 minus 1.25. Let's go ahead, let's set our, oh, that is the right size. So let's duplicate this one. Duplicate there, duplicate there. I need to call that pin 2. We need to call that pin 3. We need to call that pin 4. So we need to, it's probably the easiest would be to, well, okay, I definitely need to change my grid. What do I need for this grid? So I need to go down to 0.01 or something like that. I need to go quite a lot down. 0.1 will not be enough, so we need to go all the way down. So what is it now? It is, if we measure there, that is 1 millimeter center to center, and we need 1.25. So if we move that one, oh, that is very, very fine. Can we actually do this is probably better. What would that result in? Now, it's probably easier to calculate this actually. So that is 0. So let's see again. Oh, 1. Two 5. Oh, it should be actually one more. There. What happened there? Center, so center. It's not there yet. Did I not move this one? Where are we? Still not there. It's irritating. outside 1.6. It's probably easier if I take the 1.6, so that is 0.8. So if I do a silk screen line, wait, let's start this again. Let's go to the user drawings and actually let's create this outline. So we need the width. This is easier to actually get the grasp of. So 1.6 millimeter, 1.5 millimeter. So if I start by some random location here, oh, it is actually, oh, there we go. So let's do 1.6 millimeter to actually have that. And then we do 1.5 millimeter down. I always delete these when we're done. And then we do 1.6 millimeter there. And then we do 1.5 millimeter. What's that one? Skewed. Yes. It's skewed. It looks skewed, doesn't it? So I think the problem here is I haven't had my morning coffee. I press M for moving, and then definitely skewed. So let's kill that off again, and kill that off again, and kill that off again, and make sure that, okay, let's go completely move, and well, okay, I am really not doing this very well here, so let's move this one there and look, rotate, edit. Here we go. So it is 0 to 1.6. So now let's continue this with a fatter grid. So we go 1.5 down there, go 1.6 there, and go 1.6 there. Now it is the way I want it. So move that one out of the way, select this one, and move this one where I can do that visually. Actually, it's around there. So now let's look at this one. This is symmetric now around and on a 0.75, and this one is symmetric. This one is also symmetric around the x-axis, right? So this is where I want it, and now we can this will be indicating where these will be. They will be within that the footprints, but they will stick out. So essentially, and we can fine tune it later, but essentially we can move this pin. It should probably be roughly there, would be my guess. And we move this one. When I say move, roughly there. I'll fine tune this. these were too far out, so move again and move them in. Where we at now, if I 1.4 between them, and that was supposed to be 1.25. So I actually need them to be closer. Okay, so if we go down to 0.5 and move that one in and move that. .3. So we need to go down to okay. Now I should have done that. I was just trying to be clever. That's never a good idea. So let's calculate. So we have, it is so early in the day, I need a calculator. So let's fire up the calculator. So 0. Let's take the here. So 0.45 divided by 2. 0.225 plus 0.4 will give 0.625. So essentially, if we look at this one, on the position X, we will have to have minus 0. Minus, oh, not there. Here needs to be minus 0.625. 625. All right, there, and we will do that. This needs to be minus 0.625. This one then needs to be plus 625, and this one needs to be 625. Now let's deal with the Y position. Same calculation as before. I look at the data sheet and we see these are, we have 0.2. This, remember the axes go here, so half of that and half of that. So 0.55. No, sorry, 0. It's down here. 0.65 is the height. So 0.65 divided by 2 plus 0.15 is 475. So 0.475 will be my Y position. 0.475. The first one is minus. We can edit that one. 475. There. And these will be positive. Or 75. And 475. So now I basically have the footprint where I want it. So let me go up a bigger, probably 0.1 or something like that. Now let's make the silk screen for this included. Now I no longer need, I need these to go out Where are we? Look, we can do that. It needs to clear I think it will, actually. Actually, I need to add one more. It's okay. That's probably okay. It's kind of, it might be touching. I don't like that. Let's, got plenty of space, so let's do it like that. And okay. Let's, before we have the same problem, let's save this. Oh. I'm actually having a problem here. What happened? Right, so see that. Oh, it's untitled. Let's give it a title. Untitled, we will call it I2 RGB LED. That's okay for, I think KiCAD actually changed some things here. Oh god. Copy. Paste footprint untitled copy. How do you actually name these? Save as. Untitled copy. Okay, I2. No, that is RGB. For now, I'll just call it RGB. It probably has a name. So, okay. Oh, there we go. Okay. The KiCAD have a habit of changing. Oh, there was a rename footprint. That's probably what I should have used. So we need one more thing here. We need to make an indication of where pin 1 is. How do I do that? I'll just do wait, I'm in user drawings. Okay, I can actually do that in the, this is just a user drawing. Okay, I can do that in the silk screen actually more appropriately. So if I go to the front silk screen and I just do I'll just do an angle up there, and that is it. So if we now view in the 3D viewer, it'll just have that white thing. It will not show, the black will not actually show, so that would just be a production. That's good enough for me for now. So that was a bit of a hassle and didn't go very well. So now we can go over here and we can actually choose a footprint. And we go into the, we find the, I2C LED. In that library we should have the RGB, and we can use that as a footprint. Bum bum bum. That is good. Now let's try to well, okay, let's duplicate this whole symbol, and we duplicate one more, duplicate one more, and duplicate one more. Now, just to show you, at this point we can try to update the PCB from the schematics. So it will add the footprints. It cannot, I didn't add for the jumper. So here we have our LEDs, which I usually switch off layers. I switch up the fab stuff. That's usually just irritating. Yeah, it's not aligned very well. I can finish my footprint later, but that is basically, it's picking the footprint. It can also switch off my user drawings to make sure that these are, that's basically indicating pin 1. So let's go back here. We didn't pick a footprint for this one. It wants us to, so let's go and pick a footprint for the header, and they are in generic connectors. There is a pin header, so pin header 2.54 standard 1 times 5 vertical. There we go. Now we can update our PCB one more time, and it will have the pin header. So now we're starting to get an idea about the dimension of this board. So it will be a header, and then there will be some LEDs, and that's pretty much it. Now we have one more thing we need to create in the we go back here. Now we need our AW, this one, the AW9523, AW9523. Let's get inspiration from their data sheet. So here we have the pinout. Now this is probably the best way to do it. To have the VCC on top and the ground down here, and then so yeah, I'm reset clock and these down there. That's probably the best way to do it. So let's go in and create a symbol for this. So we go to the symbol editor, and I have my I2C LED. I can right click there and say I want to create a new symbol. We will call that symbol AW9523, and I don't have an existing one, so that's pretty much it. Let's start adding some pins. So pin number, I need to use this one. I can flip them around later. So pin number 1 is P1_0. So P1_0, and that will be pin 1. And that is a bidirectional, and that is it. So there. Now, at the end of the day, we want them over here on this side, so let's do that. And then do the next pin, which is pin 2, P11, P2, P1, up to 3. Okay. P11, pin 2, There. We create a new one. P1, 2, which is pin 3. P1, 3, which is pin 3. And then for some bizarre reason, oh, sorry, that was actually wrong. That was supposed to be pin 4. Oh, let's look at the next one, which will be P0, 0, and 0, 1 on 5 and 6. Okay, so P0, 0 on port 5, P0, 1 on port 6, on pin 6. I haven't had enough coffee this morning, so let's go back to this. Now we say pin 0, 2, and 3. P0, 2. It's pin 7, right? And P0, 3. Must be pin 8. There. Okay, then we had a ground, which was on pin 9. Pin 9. I essentially want that to be down there, I think. Once we get to that, then let's continue. 0, 4, 5, 6. 0, 4, 5, 6 on 10. So P0, 4, which was pin 10. And I caught myself in an error here. That was supposed to be pin 9. Now, this is obviously, oh, that's annoying. I should have switched that off. This is obviously the place where you can make errors. If you make an error in a footprint, it's a disaster. So double check, triple check. See, now it was 5. P0, 5 on pin 11. P0, I think it was 6 on pin 12. Let me verify that. P06 on pin 12. The 6 on pin 12. And 13, 0, 7. So P0, 0, 7 on pin 13. There. P0, what? 7? That can't be more. So I am at 1, 4, 5, 6, 7. So P on 14, P1, 4. So P1, 4 on pin. It's easier if I put this out of the way so I can see what I did before. Is pin 14. So there. P1, 5 on pin 15 would be my guess. So now I guessed, let's double check. 15 P1, 5, that was correct. P1, 6 on port pin 16. And finally P1, 7 on port 17. Move. Look. now we have all those. We just need the address 0 on pin at 0 on pin 18. Those we'll put over here. AD0 on pin 18. Simple wise, I'll put them on the other side. This will make sense in a while. So let's see what is the next. That is actually the clock and the SDA on 19 and 20. So clock, pin number 19, clock 19. Now this one is actually an input pin. It's not bidirectional, so let's change that. That is an input pin. And then we have pin the clock, we have the SDA on pin 20, and that is again bidirectional. So address is actually, let's check that immediately, that is actually also considered an input pin, right? It's not driving anything. So that is an input. 18, 19, 20. What is on 21? Uh, 21 is the VCC. Okay. So, and that reminds me, let move this one roughly down here, and while I remember it, this is actually not bidirectional. This is a power input. Ground is actually considered a power input, to be exact. So let's make a new pin, which we call VCC, which we call, that was pin number 21, right? Just double check. 21, which is a power input, and that is it. Now this one I'll put up here. Oh, I actually prefer it over here. So, and move this one. It's a little bit messy to do these. So that's 21. Ground, I prefer to have down. So let's go back, and 22 is int n. So the int indicating that it's a negative edge. So int n, I think, if I'm not mistaken, and that will be pin number 22. And that is definitely an input pin. Probably want that down there. And RSTN on pin 23. RSTN on 23. Definitely also an input pin. And finally, address 1 on pin 24. So 1 on pin 24 input pin. So now we actually have all the pins. So now we can start. Where the hell is alright. Did I miss my okay. So is that? This is actually the center. Okay, let's create the component as such. They changed text box, rectangle. Let's create the box around it, and I will usually fill with body background color in KiCAD. It becomes yellow. That's just a tradition, I think, in KiCAD. Now let's keep this grouping just because they found that necessary, so there might be a logical reason for this. Let's go there and there. I just click M for move. M. And then let's do one space. There. M. 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 Did the space again. M. 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 And M. So there you go. Now we have we can determine kind of the height of the symbol. It is obvious that we can move it up there because that will be the busy one, and then we move this ground pin in the center there, and we put BCC will be on the top. We can move this one up there, and we can move the reset pin. It makes sense to have that up, but a space or two spaces. And then we can do the interrupt. We leave that down there. We do the S reset. We can do it down here. It doesn't matter. The interrupt or reset pin I want. Why did I move that again? Let's do a little space for that. We can take these two and move them up. Align them with that. And these two address pins we can do down here. We probably don't need them. So, and interrupt there. That's pretty much it. Our symbol is created. Oh, one more change I noticed, and okay, I might have been stupid now, but let's move this. I actually want to create, move it one more, I think. We do one more pin. There is actually one more pin, and that will be pin number, that will be another ground pin on pin number 25, which is essentially and that would be a power input. So there we go. This should actually be our symbol. So let's, we can actually, should I do that in the symbol or shouldn't I? But let's go over to our schematics. We can always change this and then take our AV 95, it was there. Okay, I could have saved my breath. Somebody actually created this. Should I use my own? Well, it was okay. I mean, you can skip. I have my own, and they have those. Let's use the one in KiCAD. Actually, do I feel stupid right now? So let's put this in and let's start doing the schematics for this. So first of all, we need some power. We need a ground pin. I like to use this one. Let's add one there, and we duplicate that, and put one over there. Let's wire that up. So you click the wire and you there, and we put this one there. Next up, let's do the VCC. So we simply type VCC and we have beautiful one there, and we put a VCC in, and there we go. We also need a VCC up here, so I'll basically duplicate that one up there, and we could actually align this for these two pins. Is that better looking if we do that? Move that whole thing one up, and we can actually just do these lines straight in. We need pull up on all those lines. We need pull up on probably the interrupt line, but we don't really, that's an output, so we need a pull up on the reset line. So let's do something like that, something like that, something like that. And did I say we need a pull up on the interrupt line? Probably should. So well, we can always align things nicely, and these needs to be pulled up as well. So let's see in the schematics again what we need to do. So we need to pull up both address lines. We need to ground the other two, and we need pull up on and probably the I'm going to do a trick on the reset as well. So these interrupt, these two go to VCC. How do I do this looking good? So the address lines all need to be pulled up. I hate having these floating around, so let's do another VCC symbol here, and let's simply do it like this. That's okay, and this was grounded, right? Interrupt was grounded, so let's ground that. Right. Duplicate that one over there, and then draw. Not quite sure why they ground that interrupt. Is that clever, or is it not clever? Anyway, let's throw in some pull up resistors. So we simply search for an R, and we put in a resistor. We need an R there, and we click edit for that one, and it's our watt, and the value, let's do 1K pull-up resistors. So a 1K full pull-up resistor, we choose a footprint. 0603. They changed the user interface since the last one I used. Why is resistor? It's usually the first one that shows up. Resistor SMD 0603 metric. That's a good size. We need to find one in to give it a part number. So I will go over here. I'll go to LCSC, and I'll find a TK resistor, or 1K. It was 1K 0603. Let's find a 1K resistor. Show more results. Resistors, chip resistor, surface mount. There. And we have a very hot one, 1K. There is a 1K resistor. So this will do. So we give it a part number 0603. It's 100 milliwatt thin film resistor, 1 kilo plus minus 1%. I copy that, and I go in here in my, there I add an LCSC. There I have the footprint, and I have the, so now we can copy this. Oh wait, I don't like the location of that. Let's duplicate this. Control D. And we create one more. So now we have our pull-up resistors. I can put that one down there. I can put this one down there. I can put this one down here. And I can do clone VCC. I'll show you a little trick here, which I actually use quite a lot when I need to do this. So I can put it there and then connect it down. I can also just connect it there, and then if I click G, I can actually drag it up, and it will connect a line. It's I don't know what G is actually. There. So now I have the pull-up resistors, and now I put G to, that looks like shit, so this looks better. I am a little bit anal about that. Now, the reset I want actually to come on slowly, so I think we need a capacitor. Actually, let me, I don't want to advertise for these guys, but JLCPCB should sponsor me, but they haven't decided to do that. 100 nanofarad 0603. They are welcome to contact me and sponsor me, and I'll be happy to. Let's see, in stock. In stock basic parts. They have a basic part for that. So here we have 100 nanofarad 0603 multi-layer for 0.2 cents. Well, let's pick that one. Yageo little capacitor, and let's take the part number there, and then we go over here and we add a capacitor, and I want a capacitor on this line to ground, so it comes on slowly. I'll explain to you in a short while why. It was supposed to be E, and this is 100 nanofarad, and the footprint is 0603 C. This is really irritating. They changed the user interface. 0603. No, that's 02. Where is my 0603 metric? There. And I need an LCSC part number. LCSC. Did I copy that? I did. So that is supposed to be there. So now I can put in my. Okay, what I'm doing here, I noticed in the datasheet, let me explain this. This is unfair, I don't explain that. Let's look at the datasheet for this one. It says, under the general description, I noticed, oh, I must have messed it already. Up in the top. Trying to find that. Just here, power on. After power up, about 100 microsecond delay before reset is set to high. Now I am contemplating here not using the reset pin at all. Right, don't connect that. So I need to make sure it comes on a bit slowly, and well, that should actually do the trick. It might be too quick. I actually think I calculated it with a 100k resistor, so why don't we actually change that one to 100k resistor. Now I need to find a part number for the 100k resistor. Wait, let's go back and search there. Let's find a part for the resistors. So let's search for that part first. It is here, and they have wait. Let's first search for the 1K resistor, which we used already, and let's do a basic part in stock, which will be the absolute cheapest option, and that one is here. All right, so was that 211? It was not the one I used, so let me change that to that. No, tools. I promise you guys I'm not going to do this again on this hour. So R1 and 2 would be that one. LCSC, we need to include that in the table. Where is R1 and 2? This line. There. All right. And then we need to find, this is messy, let's do 100k resistor, same size, and see if we have a basic part. And here we got one 100k resistor. Let's verify 100 kilo ohm 0605, and we have a part number. We take the part number, go over here, we change the part number down there. So okay, now we have our pull-up resistors on the tree, on the data lines and the reset line, and we have a delayed reset. And that is pretty much all she wrote. This will be the interface size of this. You can connect it to VCC. Let's beautify this a little bit. I like to line things up. I have a few rules when I make when I make schematics. Power comes from up and ground goes down, and that is it. I absolutely hate people that put a arrow down to VCC and an arrow up to ground. I just don't like it. It's that simple. So let's see if we can get these sort of aligned. So it'll be roughly around there. Should I just... Well, let's start with the power for these. We can put this over here, and we can just draw that one all the way down to the last one. Now that probably have to be a fairly fat line on the PCB, but let's worry about that later. So now the anode is connected to power supply on all, and now we can start with these. Something like this, and up to that one. I like to sort of keep the distances to grid squares up to that one, and that one up to that one. That one will go up to that one. This one will go up to that one, and that one will go up to that one. I don't know if I have space for this. This one goes straight over. This one. That's okay. Next one. Didn't look. That looks better. And now, if you make mistakes in this, you can always go back and modify it later. It's not before I generate the PCB. And in truth is, I kind of often do it in parallel because I sometimes want to change these pins because it makes the layout easier. But that's pretty much it. So this is it. I think I want to do one more change, and the easiest place to do that is by actually moving this out. I had an idea. I actually want a decoupling capacitor. We can reuse this one, so we just basically make, and we could hook it up in the schematics like this. So this is just a plain decoupling of the VCC line. We should actually probably, because the LEDs could be power hungry, should we? I think they recommended in the schematics. Wait. I think I saw, where are we? Here. A 1 microfarad capacitor. So why don't we find one? 1 UF 0603 I'm sure we can do that. And we can find a basic part that is in stock. There we have it. It will handle 16 volt, which is more than enough for our. So let's do a 1 microfarad capacitor as well. And okay, this is not the most logical place to put it in a schematic, but right now I don't really care. So look, we put one more here, which we could call 1UF, and that's it. And we give it a different part number. So, but it's the same size. So let's connect that up to VCC and to ground. Okay, so that is pretty much the schematics complete. There is probably a mistake here and there, but I'll worry about later. Let's try to update the PCB from the schematic and see what is happening. So we got some new components, and that is pretty much it. So let me go to my usual go-to. So we start with this component. We move that. It's taking the center. Doesn't really matter where we put that, and we can move this one in relation to that. Now it will probably be easier if we rotate this. Where do we have the VCC? Well, the pins, they all come over here. So I think this one needs to be there and aligned that way. And now we can start putting the LEDs in the best positions. Let me fix that footprint before we do anything else. So let me save this and go over to my footprint editor. Oh, got a bit sloppy with this one. Put the ref up here. So let's put this one. We move this down to there. And these two I don't, on the other hand, don't care about, because I'm going to hide them in most cases anyway. So that looks a bit tight. So move that one up. And let's save this module and exit the footprint editor, go back to this, and then update tools, update footprints from library. We update all footprints, but I want to pretty much enable all the options here. Now it looks much better, right? Now we have the designator nearby. So let's see if we can find a reasonable way to put these modules where, first of all, where does it? Oh, it actually does take the center, so this is okay. So this one is the first one that sort of logically belong down there. I can wire that up, no problem. Let's see if we can find and this one I would then suggest we put VCC. That actually goes. Probably put that there, and let's move this one. That one is connected, so I can get that one. Okay, I can wire that one up. And let's look at that one, and that one sort of hooks on the corner pins. So I'm beginning to get an idea here. There. How about that is how we do it. So let me do a board outline, and now I'm getting the idea. So you go to the edge cut layer and you draw a line, and well, let's start there, and we make it, how big should we make it? 1.5 centimeter, and let's see how. I think that's excellent. Meanwhile, let's change the designator on this one and move it down to this side on all the LEDs. I will there. There. Align that one with that one, but probably roughly aligned there. And how would that look? Oh, there is some capacitors and stuff. Let's look at the 3D. We have a sample for that one. That is excellent. And I don't have a LED. I could go look for one. So that will be the 5 LEDs and this one. Now let's put these capacitors and resistors where they would fit in nicely. So that was decoupling. No. This will be a little tight actually if we do it this way. I think we need to extend this board a little bit. So let's try to how big do I have to make it to actually fit all these components over here? Let's see. C1, what is C1? Let's look at our schematics. Actually, let me immediately, because let me annotate and let me reset the existing annotations, and let's re-annotate them. So C1 is the 1 microfarad, which should be as close to the VCC pin as possible, I think. C1 will be the relatively big one that we could put up here. Be a decent location for it. C2 will be one of also, oh, C2, do that. C3, actually related to the reset pin. And then we have the resistors. Still a bit tight, this board. Did I actually make it bigger? I think I need one more row of these. let's try to move. Something like that. And let's move this resistor as there. This resistor. That's the data lines. We can move that out of the way. So this will be okay. We can put that there, and we can put the last resistor there, and then we can move this one. Well, we actually don't have to move this one out there, and we can move this up there. Let's adjust the edge cut to our new size, and I noticed another mistake I want to fix. Well, let's see how that looks. View 3D viewer. Well, we can definitely spread these out a bit more to make it look more balanced. It's no electrical reason to do that, but I noticed this one I want to remove. I don't want to show that, so they used to have, is that knockout? What is knockout? They changed. Okay, so I'll put it out there. I think I'll just spread these out more even, and then we are pretty much where we're at. I actually never set this up correctly, so let's go to the board page settings first. We need the revision. We need the title, and we need the author. We need the author email. Okay, has it been? Oh, there is one. Just caught you. I add the stream to a playlist. Julia, what time do you usually start? I don't have a usual time to start because this is the first time I'm doing this stuff, and I'm just right now playing around with the format. I don't even know if I want to do this on a regular basis. I'm essentially just at the moment I'm kind of just messing around, and we'll see where this actually leads. Page setting, I had the page setting board setup. Let me go through the board setup because this is kind of so my physical stack up. I want to do a thinner board, so let's do this. Adjust the dielectric to 1.2 millimeter. That makes the board a bit thinner. It doesn't need, it's a very small board, so it's kind of silly if we look. Text graphics, that's all the defaults is design rules, constraints. Now, minimum clearance. Now, I know I just got into a habit because I can usually live with it. So I set this to 6 mil, 0.125, and my track width, I set that to 6 mil as well. Minimum, I leave all these pretty much standard. So predefined sizes, I will usually add some tracks. I have the 6 mil. I'll add 9 mil. I'll add 12 mil. I'll add 15 mil. And I will add 18 mil. There. That is my where is my design rules? Predefined sizes, teardrop, lengthening patterns, net classes. Okay, my net classes, I will do my 6 mil track width, 6 mil. Do not ask me why. I tend to do a via size of 0.7 with a via hole of 0.35. That's just some standards I have gotten used to. I know most PCB manufacturers today, you can probably tighten that down a bit and make it even more tighter than that, but this is basically what I usually do. So now I have a setup of the board. Let me do one more thing. Let me add a ground plane to this. So we have that over here, there. Now I will add that around the entire board. So this will be on FCO. So we will do a copper layer, we will do both layers, and we will tie that up to ground. And clearance, again, I will use 6 mil, 6 mil, 6 mil, and I usually make these 12 mil, if I can get away with it. Just values that I have gotten used to using, and if it works, don't fix it. If you're starting up now, you might as well do it the way you prefer to do it. That is perfectly understandable and perfectly acceptable. Now, I think these are... this one is perhaps a little bit too close to the edge. We can move these. I move that. I move this. I can move this out a bit, actually, to make these aligned. Was that aligned? Yes, that looks like it's aligned. Okay, let's just... now I'm just fiddling to kind of make it look more evenly distributed. Let's move these down, and let's move this one to the center. Let's look at this. B is float filling. Let's look at the board now. 3D viewer. Still a fairly small board. Right, so that's pretty much it. So let's see how bad the routing is going to be. What can I do? Where is my VCC on this? It's there, and you have these two. So I think we should probably rotate this one and rotate this one, and then move those. Move the... Should I have all those on the back side? I think I should probably do that. But let's start by doing a fat trace-ish, 15 mil or so, between these two and up to that one. This will be a good start. Let's do probably 9 mil into this one, because that's pretty much all I can do with that pin there. So now we have the power on there. Let's do the power over to the to these. The easiest would be, they probably don't need more than 9 mil each. So I'll pull that out like that, and then I'll do a wire there, and I will continue that up to the VCC over there. I'll do exactly the same over here. I have a wire, and I'll connect that over to that wire. I will do exactly the same. Uh, was that it? Sometimes annoys me. There. That's probably better. So let's go in and we finish. No, we were. Oh yeah. Finish that. There. Actually, we could. Can you drag? You can, but you might not want to. Let's try to delete that trace, and then we can take that one and we can actually put that closer. That is nicer. We can delete that one, and we are on 9mm. So there. Let's try this one. So let me there. You just press V, right? So you go out, you press V, and then you can drag it up. So let's do the fill, and let's look at what we have so far in the 3D viewer. You can see we have this big fat, oh, it's not fat actually, so I might actually need to fatten that a bit. Goes out, and we don't have this powered yet, so we need to do that. But my idea was you just do that with a wire and then hook up to this one. So we'll do all the data traces on this side of the board. What was this capacitor, and why is that not? I think we need to switch these two capacitors. I think that was the reset thing. So I've been lazy. Let me do this straight away, because this is getting a bit hard to follow. So let's go into the schematics, and actually let's put some labels on some of these nets. So this net is VCC. No doubt about that. This one is SCL. There. This one is SDA. This one is, I'll just call the net RST. RSTN, it doesn't matter. And ground is ground. So let's do that, and let's now update our schematics with those values. And let's look over here, and now we can see these things. So first of all, let's nuke that connection, and let me move that capacitor. No, let me move that capacitor out of the way. Let me move that capacitor, but rotate it up there, and I can see I have another stupid. This was RST, this was RSTN. This is actually the capacitor that should be up here. So we do have a bit of a I wasn't very clever when I put these components, so let's see. I want these two capacitors are the main capacitors, so C1 and C2. C3 is a little bit different. So C1, where is C1? Is down here. So I want this one up there. That is C1. C2 is that one. Let's verify that is correct. So C1 and 2 I want up there. And then I do my, that was, I think I did 15 mil with that. So now we can just, oh, there, down to that and into the VCC pin. And that's all good. Now we have the reset, which come in here. The reset there is a reset and there is a capacitor that goes with it. So we can put this one. There. So we'll have ground, we need a VCC down here. That might be a little bit, no, we can just pull that straight down. That's not a problem. And then we have a resistor here, which is essentially the clock. And where does that go? That goes in there. Okay, this is going to be, no, I can pull that up on the other side. That will be okay. And then we have, where is the other? The SDA is there. Yeah, we can't. Where is that one going in? There, and where is SDA is going? They're both going up, so we should basically, this was stupid, we need to clear all that, and we need to rotate that one around, and then there. So now we have SDA and SCL goes above it. Oh, this is annoying, but look, this is not going to carry too much power, is it? It is actually going to carry a lot of power. But if we do, well, how do we do this? Actually, I'm thinking, because okay, it costs nothing these days. So what I intend to do, where is 0. Solid fill thermal 0.3? This is normally not that big. Where is that defined in the settings? Board setup, board editor, physical stack up. It is not board finish. Text and graphic constraints, design rules. There must be some spacing around holes via silk screen. Some fill strategy, minimum predefined sizes. Okay. That classes violation. I don't actually like. Okay, this is a problem with this format because I do have a question. What is this board going to do? And I explained that in the start, so I guess I need to announce these up front. So let me do this. The idea is basically to use a GPIO expander and use that GPIO expander to use the GIO expander to drive 5 RGB LEDs, and this is just so it'll be an I to C will drive this one, and that one will set the values of 5 RGB LEDs. So it's basically, but the point of this is to do the project from scratch in KiCAD, and that is all it takes. That's all I'm doing here. So what else? What does this board do? Are there any required? And below I put, did I do something? Never mind. In the industry standard, yes, there are. It depends on your manufacturer. If you have this board, wherever you have this board manufactured, they will have some constraints that they are operating to, and you better stick within those. And my values, the values that you saw me choose, was based on one of these vendors way back. They had that. If you look at, okay, I don't really want to talk about JLCPCB for reasons, but they have a page here called capabilities. And if you look at the capabilities, that is essentially where you get all these values from. And if we look at the traces now, you can see min track width is 4 mil actually now, or 0.1 or 4 mil. Spacing, minimum spacing, track width and spacing, 2 layer, 4 mil, multi-layer, 3 mil. So I'm actually quite far away. I could make this much tighter, and I will probably one day I will need it, and then I'll do it there. But at the moment, I got tons of space. So that is pretty much it. I don't know if anybody is still around. There might be some. So we can do here and go into the PCB editor again. Okay, let's move on. Maybe here. What I was about to say, let me make a dramatic change here by doing the board setup, physical stack up, and board editor layers. Let's make this a 4-layer board. The thing is, it costs exactly the same these days, and it just makes some things a lot easier. So I'll do this as a 4-layer board. It's definitely not necessary, but I'll do a 4-layer board, and that means I'll change this to make a, we'll do the internal twos. I'll do that as a ground plane. The reason why this is make things easier is that now I can make the in one VCC 6 mil, 6 mil, 6 mil. So there. Oh, I don't know why. Do VCC. So also always finish this. Now let's look at this layer. Still don't understand why that distance seems pretty big, but it's probably okay. So let's remove the view of that. Now, the reason why this is clever is that now I can actually pretty much remove these long one, because all I need to do is place a wire. And that will hook straight into this layer, which is underneath, which is in the center. So the power will be in the center. It makes sense to have these two on still, and because that decouples that, and then I can do down in VCC, I can do the same trick. I can just essentially do a copper, and I can do a wire. There, will do fine. Well, that was too thick. So I need to do the 9mm to fit on the package. So let's try that again. There, and we'll do a wire there. Give space for the reset pin, and these are just pull up. So it's I just basically do it. Wait, there's some alignment issues here. Something is wrong. I don't like that. They're not aligned correctly. This is correctly. Why did that happen? I don't align with my... That is... That... what is what? That is the capacitor. We put that over there. Move that. Move this up there. This. Proper aligned. Okay, let me explain this. Rule number one I use, I never, ever, ever be afraid of ripping up traces if you can find different placement of your components. By far, the most important when you're designing a PCB is the location, the placement of the components. Once you have the component placed, it is really quick to route the board. So I don't normally worry about these things. So SCL is there and SDA is there. That is quite okay. So let me just show you what I have in mind with this. So this one can basically go straight over there. This one will go straight over there. This one will go straight up there, and this one will jump through there. And that will be the pull-up resistors, and we just need, let me do that right away. So I'll just do a V there. That's it. Right. This one will hook up into the green layer, and it will take the power from the center layer, and so will everything else in this. And we can do the reset as well. So there, reset there, reset there. We have a VCC there. Did we have two VCCs? And down here, really matter where you put it. Okay, and pretty much all the routing that is needed on this board, except we do that one. Let's see if these, if we are going to get into trouble with the LEDs. So this one probably need to go that way. Let's in tools, route, interactive router settings. I need to make that able to shop everything pretty much. So let's try again. Now we can, and I switch, and this one goes in. That's not too bad. I can live with that. It's a 9mm. I can live with that. Let's see how it goes over here. This one goes there. No, hang on. And this one I can, it needs to go the other way around. Okay. I can always fine tune. Are you kidding? I didn't notice that before. Long have I been at this? This is almost running at 2 hours, isn't it? What? There I can see now how these layers will reduce the number of traces on the top border. Each of the 4 layers are insulated from each other. Yes, yes. Not a boss. It's just a. If you flat fill it, a layer is just a layer. But if you put these zone fills in, it basically fills up the layer. You can see over here, you can toggle between. If we look at this layer, for example, that is just a ground layer, which is internal. And if we show the zone fill, you can see it's just one big zone fill, but it is isolating the VCC wires that come down, but it is connected to everything that is ground. So whenever I put a wire that is ground, it will connect to that inner fill as well. If we go to this one, which is the VCC, you'll see these are actually connected to the VCC, but they will not connect to anything else. It's connected up here to the VCC pin, but it is not connected. All handled automatically. Normally you won't show that because it is getting really messy. So I have 3 layers with a ground fill and 1 layer with the power fill only, and that just makes it dramatically reduces. Now, I think I've figured out idiocy. I think I want to actually remap my LEDs, but I think I'm going to do that in the next video because I'm getting a little tired of this. So I think in the next video, what I'm going to do, I'm going to commit this so far, and I'm going to continue this video maybe tomorrow and finish it off. It took a bit longer than I planned to do, and I will continue this, well, basically tomorrow, so probably around the same time as I did today would be a good start. Well, he's still around, Jesus. I didn't expect me to have any viewers, and there are more. Let's see, Peter Fan. Just want to thank you for all the content you created. We appreciate it. Well, okay, I enjoy making it. I'm not, to be honest, I'm not sure I enjoy this live format. I enjoy doing the videos. It's sort of I like the process. I mentally prepare and then I just shoot it and that's it. Be done with it. This one, I sort of mentally prepared to what I wanted to do, but you are seeing me through all the struggles and fights, and at the same time, I haven't actually done much in KiCAD for the last 6 months, and it's gone through an updated version, and that's essentially some of my struggle. They sometimes tweak the user interface a little bit. What is... I'm not familiar with KiCAD, but there should be a tool that creates teardrops on the true holes. It make very nice. There is. I never bothered to use it. I don't really even think it looks good. But that is just a matter of taste. Transition became very thin, and well, these traces are not that thin. But okay, I mean, teardrop. I don't know where to configure that. But okay, I'll read up on that and I'll do that in the next video. I promise. That was, yeah, I think I'm up to date with all the comments. So that's it. Don't ask anymore because I'm going to end this video here. I am going to update this page, which is the I2C RGB LED board, and I'm going to continue this video and finalize the design. My original tentative plan was actually to bring this all the way up to a point where I could order a board and actually get it. Am I going to do that? I don't know, and I actually don't think so. I'll give you a little bit of the backstory. Now, it is not actually social media, but I've been running this STM32 world wiki page for, I have no idea, 5-6 years. And it is very, very well indexed by Google, and there are some things on this page that is, if you Google about it, this is the page you end up on. And I actually approached JLCPCB. I approached them. They used to have, if you had a page with more than 2,000 followers or whatever, they would sponsor some things you could do, some trial runs. And I sent them email, say, yeah, I think I qualify, and they never bothered to respond. At the same time, without even asking them, PCBWay approached me, say whether they could sponsor some of the stuff I did. The problem with PCBWay is that it is harder to do assembly of small series of PCBWays, because I will need to buy the components, have them shipped to PCBWay, and then they can do the assembly. So I decided at the time not to not to continue it any further. But I mean, if someone like JLCPCB wanted to sponsor these, I essentially don't want to pay for the production of these prototypes, but I make everything publicly available. I think that's a fair deal. That means that somebody else might actually order the same from them, and they make business that way. A viewer from Mexico City. It's incredible. The internet. I mean, I'm an old guy and I've been around since the early days, and it is absolutely amazing. Julius, where are you from? Julius Caesar. One would expect Rome, but I suspect maybe not, considering the hour of this video. So that's about it. I'm kind of going now, so maybe I should just continue a little bit. How long has this video been running now? Where do one see that? 2 hours 15. And a viewer from Canada. Incredible. Just for the record, I'm in Malaysia, if any of you have any doubts about that. So here it's kind of early morning. It is amazing. It is amazing. And I guess the benefit, yeah, okay, let me put it this way. As I said short while ago, I enjoy doing the videos. It's kind of it's a mental process. I prepare, I get an idea, I mentally prepare, and then I just bloody shoot it and done. And I'm done with it. This live stream is a bit more improvised, and I'm not entirely sure how I feel about it, because I mean, it's kind of like intrusive in a way, because you get into all my mistakes and all my bad calculations, and so yeah, I don't know how I feel about it, but on the other hand, it helps generating more of a community, and I suspect that's a good thing. Now let me show you. It is linked on this YouTube channel in the explanation, but I would suspect I would like to generate a bit more of a community and discussions about things. That's always a good thing. Go to our Discord server. We have a Discord server. It is linked, and it is actually getting somewhat active. I used to do a lot of that stuff on Facebook, but I made a joke Facebook didn't like, and they decided to ban my Facebook account for life. So, can I do that on a video to Facebook? That's it. I'm done with Facebook, but it was a pity. I actually had quite an active group on Facebook, but that will not happen anymore. I like the live stream because I can insight. Yeah, I need to change the setup of my setup. The problem, I explained that very early on, Julius, but you were probably not here. The problem is I have one screen that I work on, and that is, can I get that? Okay, another thing is my preview is not live. It is like a second or two after, which makes it really hard. But I have a screen I work on, which is there, and then I have a screen over there where I usually put documentation and stuff, and the chat is all the way over there. So it's actually really hard. Discord link, it's go to the description of the channel, the STM32 World channel. It is there. You have to generate an invite link and stuff like that. So it's hard for me to show you now. So please, well, okay, hang on. You're right, I can actually participate in the chat. So if I go in here and I say invite to server, I can probably copy that link and I can probably paste that there. There you go. So yes, I could. That is the Discord. And yeah, again, I'm not sure. Oh, a final thing I should say is probably that the live stream, I tend to work slightly disjointed. I have like 2 or 3 things I do at the same time, more or less, and I swap between them. And that is another thing I have against the live stream, that I have to be very, very focused on one thing for a long time, and that just maybe doesn't work very well for me, that form. I am going to finish this board to a point where it could be ordered. If JLCPCB or somebody else want to sponsor the production, I will actually generate the production files and order and show you the result. And I will then actually do a regular video where I do a video on how to interface with this I2C and make a library for this particular board. That is sort of the plan in my head. How far it goes, we'll see. I don't really get paid for this stuff, so yeah, well, that's wait, we have a, that must be you, Caesar. So you are actually, your name is Caesar. What are you from? What, Brazil, South America, or I'm just curious. Did you write it? Colorado Springs. Okay, America. Okay, that's interesting. Oh, okay. So now we're actually getting users on the channel. That's cool. Yeah, I guess that, Caesar. Yeah, yeah, yeah. Okay, I need my breakfast, actually. I haven't had breakfast, so I will end this channel now. I'm sorry, it's just getting active. Now, I'll probably try again tomorrow morning around the same time and finish this stuff, if I wake up in time and I can do that. Otherwise, I don't think I missed... I don't think I missed any of the messages. It's very hard to look at the messages while I'm working on something, so maybe I need to take a few breaks and do that in between. So 55 people have been on this stream, but a maximum of 6 concurrent, and most people have survived about 8 minutes, which is actually quite impressive. Anyway, as I have threatened, I am going to end this now, and I will probably continue this one tomorrow, roughly around the same time. I'll do it 8 o'clock in the morning here, which will be I don't know. It is New York City is exactly 12 hours out of sync with me, so 8 o'clock in the morning will be 8 o'clock in the evening the day before, and then you can calculate yourself from there what time it will be in your time zone. I'm missing out Europe at this time. Europe is still fast asleep unless it's a night owl. So yeah, there's no time I can do the whole world in a convenient manner. So anyway, this one was probably the most fumbling, especially in the beginning. It was early. I didn't have my morning coffee, and I I fumbled a bit in the beginning, but I think it's going better now. Yeah, Julius, see you tomorrow. That is fine. I will do this tomorrow. Okay, guys, bye-bye. I'll end the stream now. Bye-bye. The stream will stop immediately.